Okay, today we're going to talk about indices in proper. We're going to be discussing about indices and we have laws of indices. Okay, what will be the rules that will be guiding us? These are things that are supposed to be guiding us while calculating. One of the rules is what we call the multiplication rule. Number one, we call it the multiplication. Okay, the multiplication rule. So in this case, this one is when you have something like, let's say, a raised to power m times a raised to power n, then it's going to be what? A raised to power n, m plus n. A raised to power m plus n. So what this multiplication rule is saying that when you have a power of any value, then the powers are going, and if the powers are going to be addition. Okay, if this is multiplication, if this is multiplication, then the powers is going to be what? Addition. So this is what we call the multiplication rule. Number two is what we call the division. Okay, this one is another one called division rule. For example, if I have a raised to power m divided by a raised to power n, then it's going to be what? A raised to power m minus n. Are you clear? Let's say, for example, if I have something like 6 raised to power 4 divided by 6 raised to power 2, then it's going to be what? 6 raised to power 4 minus 2, which is equal to 6 raised to power 2. Okay, this one is what we call the multiplication rule. Is that taken? Then the next one we're going to talk about, next rule is called the zero index. Number three, we call it the zero index rule. What does it mean? The zero index rule is just simply talking about that in a situation where you have a raised to power, I'm coming. Let's say we have a raised to power 5, okay, divided by a raised to power 5, then it's going to be what? A raised to power 5 minus 5. So therefore a raised to power 0. So when a raised to power 0 means what? Equals 1. So what does it mean? It means when you have a raised to power 0, then it's going to be equals to 1. A raised to power is equals to 1. So this is what we mean by what? The zero index. Number 4 is when we have things like we call this one the negative index. Negative index. This negative index, okay, what does it mean? For example, if I have a raised to power let's say a raised to power minus 1, so that means it's going to be what? That means it's going to be 1 all over a, 1 all over what? A. This you have what? The negative. Okay, a raised to power minus 1. Okay, or for example, if I have a raised to power minus m, okay, that means it's going to be what? 1 all over a raised to power n. Okay, something like this. This is what the negative index actually mean. Is that clear? So these are certain rules. We're going to look into more rules that will guide us while solving this. Because these indices, the rules must be respected. It really must be respected. And without the rules, you won't be able to do it to solve question. So let's say number 5 rule is what we call this one raising a power to another power. Okay, raising a power, okay, to another power. Are we clear? What does it mean? It means that, for example, if I have a raised to power m, open and close bracket, raised to power n, then it's going to be what? A raised to power what? Mn. Because when you look at it, this is power. This one is also what? Power. Okay, so when you have that power, then it's going to be what? M times n equals to a raised to power mn. Okay, this is what it means. For example, if I have something, let's say I have something like this. 6 raised to power 2, open and close the bracket, raised to power 3. Okay, that means it's going to be 6 raised to power 2 times 3 equals to 6 raised to power 6. Okay, so this is just the rule, raising a power to another power. Then we go again to rule number 7. I'm sorry, rule number 6. Now, this particular rule is just having something like this. If I have, for example, if I have a raised to power 1 over n, okay, when the power is a fraction, okay, a raised to power 1 over n, then it means that it is the n roots of what? Of a. Are we clear? If I have a raised to power 1 over n, it means what? The roots of n, I'm sorry, n roots of what? A. Okay, let's say for example, if I have a raised to power 1 all over 2, that means it's going to be what? The square root of what? Of a. And again, if I have a raised to power 1 all over 3, okay? Let me put 2. If I have a raised to power 1 all over 3, it means what? The cube roots of what? Of a. If I have d raised to power 1 all over 4, it means what? 4 roots of what? Of d. Are we clear? This is just the rule. And this particular one, when you have a fractional, we normally call this one fractional indices. This kind of indices is what we call the fractional indices. Okay, so that's it. So suppose I have another one. Okay, so I will group this number 6 with call it the fractional indices, depending on how you want to call it. Are you clear? So this is what it means. Another case again of this fractional indices is, for example, if I have a raised to power m all over n, something like this, a raised to power m all over n, then it's going to be the n roots of a raised to power m, something like this. If you don't see it in a situation like this, you can see it. It can also be like this. The n root of a, open and close bracket, raised to power m. Are we clear? So let's say, for example, but eventually I have a situation like this. I have 8 raised to power 2 all over 3, something like this. It means that if I have a situation where it is 8 raised to power 2 all over 3, then that means is what? The cube root of 8 open and close bracket raised to power 2. So therefore, the cube root of 8 is what? Is 2 raised to power 2. How do I know the cube root of 8 is 2? The way I know that the cube root of 8 is 2 is, for example, this cube root means that what number will you multiply up to 3 times that will give you 8? So when you look at it, 2 times 2 times 2, 2 times 2, 4 times 2 will give me what? 8. So that's the cube root, okay? Open and close bracket raised to power 2. So therefore, it's going to be equal to the cube root of 2 power of 2 is equals to 4. Are we clear? So this is how to solve questions like this. So this is just the rules guiding this indices. Once you understand these rules, you can easily solve any question, be it complex or in any form. Okay, so right now we are going to solve one more. We're going to solve a lot of questions regarding this type, regarding indices. For example, if I have 4 raised to power x equals to 32, how do I solve this? So to solve out this part of question, so I am going to say that break this term down to the lowest. I'm going to break this to the lowest. This 4, I'm going to break it to the lowest number. So it's going to be 2 raised to power 2, okay, open and close bracket, raised to power x equals to, break this one down, it will be 2 raised to power 5. Because 2 times 2 times 2 up to 5 will give us 32. So therefore I'm going to say 2 raised to power 2 times x will give us 2x equals to 2 raised to power 5. So this 2 will divide this 2. So you're going to have 2x equals to what? 5. Divide both sides by 2. This one cancel. You're going to have x is equals to what? 5 all over 2. So very easy to solve questions like this. Another one we're going to solve in again. So peradventure, I have a question that says that 3 raised to power 2x is equals to 1 over 27. So if I have something like this, I'm going to break this one to the lowest value. So I'm going to say 3 raised to power 2x is equals to 1 over, then this one is going to be what? 3 raised to power 3, because 3 times 3 times 3 will give us 27. So I'm going to say 3 raised to power 2x equals to, now I'm going to remove this fraction. I will remove this fraction and put it in an inverse form. Put it in an inverse form. So it's going to be what? 3 raised to power what? Minus 3. 3 raised to power minus 3 is something as 1 over 3 raised to power 3. Okay, so now this 3 will cancel this 3. It's going to be 2x equals to minus 3. Divide both sides by 2. 2 cancel this. X will be equals to minus 3 over 2. Is that clear? So this is how to solve this kind of question. We're going to solve another questions, so to get a clear view on what we are doing. Another one again, we have sample open bracket 0.25 close the bracket raised to power x minus 1 is equals to 32. So once we have this, the next thing I'm going to do is what? I'm going to remove this thing. I'm going to remove this decimal point, put it into fraction, convert this thing into fraction. So this 0.25, I'm count 1, 2. So it's going to be 25 all over 100, open and close the bracket, raised to power x minus 1 equals to 32. Or rather, let me break this one to the lowest. So it's going to be what? 2 raised to power 5. Okay, so now we roll this. 25 divided 25 will give us 1 over 25. 100 divided by 25 will give us what? 4. Open and close bracket raised to power x minus 1 equals to 2 raised to power 5. Is that clear? So now we've done that. Now we are going to break this 4 to the lowest. Break this 4 down to the lowest. It's going to be 1 over 2 raised to power 2, open and close the bracket, raised to power x minus 1 equals to 2 raised to power 5. Now I'm going to put this fraction in an inverse form. Putting it in an inverse form is going to be 2 raised to power minus 2. Are we clear? 1 all over 2 raised to power 2 is going to be 2 raised to power minus 2, open and close the bracket, raised to power x minus 1 equals to 2 raised to power 5. So therefore, I'm going to have 8 as such. This is going to be 2 raised to power minus 2, open bracket, x minus 1, close the bracket, equals to 2 raised to power 5. Then 2 raised to power minus 2 times x will give us minus 2x, minus 2 times minus 1 will give us plus 2 equals to 2 raised to power 5. This one will cancel this 2. So we're going to have minus 2x plus 2. Minus 2x plus 2 equals to 5. Okay, so now collect the like terms. We are going to have minus 2x. This plus 2 will cross over to this place. It's going to be equals to 5 minus 2. Okay, so having done that, the next thing we are going to do, we are going to say that minus 2x, okay, equals to 3. Okay, so divide both sides by minus 2. Divide both sides by minus 2. Minus 2 divided by minus 2. We're going to have x equals to 3 all over minus, or we're going to have it as what? Minus 3 all over 2. Are we clear? So this is our final answer. Very easy to attain. So I've gotten our x. So I just wanted to show us this question. Okay, one last one we're going to look into. One last question that we are going to look into. Suppose we have a question that gives us something like this and say that x raised to power minus 2 all over 3, x raised to power minus 2 over 3 is equals to 16. Okay, so when you see this situation like this, and the next thing we are going to do is this: we are going to multiply. Okay, multiply both sides. Once you see this question, you're going to say multiply both sides by the power. Multiply both sides by the power of 3 over 2. By the power of 3 all over 2. You're going to multiply both sides by the power of 3 all over 2. So we're going to say x raised to power minus 2 all over 3 times 3 over 2. Okay, equals to 16 raised to power 1 times 3 over 2. Okay, because this 16 has a 1 here. So, good. So, multiply both sides. Then, this 3 will cancel this 3. This 2 will divide this 2. So, x is going to be minus 1. Okay, equals to. Then, this one is going to be what? 16 raised to power 3 all over 2. Are we clear? So, having done that, we are going to say x raised to power minus 1 equals to, then we are going to put it in the roots. It's going to be what? The square root of 16, open and close bracket, raised to power 3. So, therefore, we are going to have it as what? That x raised to power minus 1 is equals to the square root of 16 will give us 4 raised to power 3. So therefore x raised to power minus 1 is equals to 4 times 4 times 4 up to 3 times. It will give us 64. Okay, 4 times 4 16, 16 times 4 will give us 64. Then remember, this is having what? Raised to power minus 1. So we are going to multiply. Okay, so multiply both sides, by the power. Multiply both sides by the power. Okay, sorry, let me use this side. Go to space. So once we're going to say multiply both sides by the power of minus 1. We're going to multiply both sides by the power of minus 1. So therefore this one is going to be x raised to power minus 1 times minus 1 equals to 64 raised to power 1 times minus 1. Okay, so x minus 1 times minus 1 is 1. So just this one equals to, then this one is going to be what? 64 raised to power 1 times minus 1 give us minus 1. Okay, so therefore x will be equals to 1 all over 64. You see that you leave it like this: 64 raised to power minus 1 or 1 all over 64. So this is our final answer. Okay, so this what we just did so far, understanding about what indices is very understandable, I believe so. So at this point, I was just going to say that this one is what? Indices 1, part 1. What we just did is part 1. Okay, so in our next video, we are going to see how to do part 2. Okay, part 2 of indices. Thank you.